Lesson 10.6 is over segment lengths in circles. So we're looking at chords, secants, and tangents, and looking at their segments because some of them intersect in different places, and there's a relationship between the products of some of those segments. So there's three theorems. The first one, if two chords intersect in a circle. Here we have the first chord, and here we have the second chord. Then the product of the measures of the two segments of the chords are equal. Alright, that's a little confusing to understand, but what it's talking about is when they intersect at point C, this segment here times this segment here is equal to this segment times this segment. So we would write that out and express it as segment AE times segment EC is equal to segment DE times segment EB. Now, if we were to give these values, let's say this segment here has a length of 4, this one has a length of 3, this one has a length of 6. Okay? And say we don't know what this one is. Alright? We could call that X. So then 4 times 3 is equal to 6 times X. 12 is equal to 6X. Divide both sides by 6. 2 is equal to X. So DE would equal 2. So this is a way of problem solving, a way you'll be presented with problems, and you just have to remember that their products are equal to each other. Alright, the next theorem. Notice they are extremely long. If two secants are drawn to a circle from an exterior point, so here we've got two secants drawn to a circle from an exterior point, then the product of the measure of a secant segment and its external secant segment is equal to the product of the other measures of the other secant segment and its external secant segment. Whew! Okay, that's long. So this is what we're going to do. MR is the entire secant that we're looking at, the entire segment. NR is the entire secant that we're looking at over there. If we take that length and multiply it times the length of its external part, then we can put them equal to each other. That's what we're looking at here. So we would write that out. That segment MR times its external part PR is equal to the other secant NR times its external part QR. Alright, now let's give it some measures. We'll say that MP is equal to 3 and that PR is equal to 5. QR is equal to 4. Do not mistake and think that these have to be congruent. They do not, because it all depends upon where it's drawn inside the circle. Okay? Say we need to find NQ. Alright, we would set this up as MR. The length of MR is 8. The entire segment is 8. Times PR. Well, PR is the exterior. That is 5. NR, this entire segment, be very careful right here. That's not 4x, but it is x plus 4. And all of that is one term, so I'm going to put parentheses around it. All right, or I say one term, it's one number, times its external part, QR. 4 is the external part, so I'm going to put it here. Now, this is going to require the distributive property. So 8 times 5 is 40. 4 times x is 4x, plus 4 times 4 is 16. Now we solve for x just like we did in algebra. Subtract 16 from both sides. You get 24 is equal to 4x. Divide both sides by 4. You get 6 equals x. So this interior portion has a length of 6, which means the entire secant in R, or that secant segment, has a length of 10. Okay? The last one. If a tangent segment, remember a tangent is outside the circle and it touches the circle at one point. If a tangent segment and a secant segment, here's your secant segment, are drawn to a circle from an exterior point, then the square of the measure of the tangent is equal to the product of the measures of the secant segment and its external secant segment. Okay, what we're saying there is if you take this tangent and square it and set it equal to this secant times its external portion, you can solve for any missing parts. All right, so we're going to write this out as SR, segment SR times TR. So it's the very same as it was up here in this previous one. We took the entire secant times its external part. We're doing the same thing here, but since it's equal to a tangent, we're taking the tangent and we're squaring it. Okay? Now, let's say that ST is equal to 7, TR is equal to 9, and UR is X. That's our unknown. So SR, this is where you got to be careful. A lot of people want to say 7 times 9. That's not correct. We need the entire secant, 7 plus 9, which is 16, times the exterior portion, 9. And that is equal to x squared. So we have 16 times 9, which is 144. Now remember, we never leave an answer in terms of x squared. We want to leave it in terms of x. So we're going to take the square root to undo the square. And the square root of 144 is 12. Be a positive 12 because we are talking about a length of measure here. So that's how we would find the length of tangent segment UR. All right, there are some practice problems on the back side, but we will be covering those in class.